Hey guys, Mr. B here again, bringing another math video. In this math video, I'm going to continue on sort of building on the topic that we just discussed in the last two math videos, which was using the prime factorization. And the last video I talked about using it to find the GCF. Well, in this one, I'm going to talk about the LCM, which means the least common multiple. So there's a couple different ways to do this, but my preferred way to do it is using prime factorizations. So some of you guys have probably seen, like, if you had something like, I don't know, 12 and 24, and you're trying to find the least common multiple. So you'd start listing multiples of each one. So 12 times 1, 12 times 2, 12 times 3, so on and so forth, and then you do 24 times 1, 24 times 2, and you'd wait until you got a common one. So this is the LCM for 12 and 24, which is actually 24. However, what happens when you get really big numbers, or if you have two numbers that it takes a really long time for the LCM to show up in the list? You might be listing, 15 or 20 numbers before that actually happens. So the best way to avoid that happening is through using a prime factorization. So the numbers that we're going to do it for is 15 and 24. So we're going to find the least common multiple for 15 and 24. So least common multiple basically is the smallest number that when this number is multiplied by a number and this number is multiplied by a number, that we get the same number. So the smallest number for which that occurs. So in the last one we saw that 12 times 2 gave us 24, and also 24 times 1 gave us 24. So 24 was the smallest number that showed up in that list first. All right, so let's try it for 15 and 24, except we're going to use prime factorization. So again, we might want to write our primes, just have them handy, memorized, whatever. So there they are, 2, 3, 5, 7, 11, 13. So what we do is we take 15 and we divide it by the smallest number that it's divisible by of prime. So the smallest one is 3. And that's equal to 5. So 15 is pretty easy. We actually don't get an L, we just get, the bottom part of the L. So 3 times 5 is 15. So 15 is 3 times 5. And 24 is divisible by 2. So we take 2, and that's equal to 12. And 12 is divisible by 2 as well, and that's equal to 6. 6 is also divisible by 2, and that leaves us with 3. And 3 is a prime number, so we're done. There's our L. And so we end up with 24 is equal to 2 times 2 times 2 times 3. And for LCM, I like to write mine, well, actually, it's not I like, you should write using powers. So 2 times 2 times 2 is the same as 2 exponent 3, so 2 exponent 3. And then we got 3. So for how do we, for GCF it's pretty straightforward. We look at what's common in each one. LCM is a little bit different. For LCM, we have to find the highest power that occurs in each prime factorization. So, or the highest power occurs for each number that occurs in any prime factorization. So the numbers that we get from this prime factorization, so we get a 3 and a 5 from this one, and we get a 2, and we also have a 3. I don't need to write it, it's already there once. So basically what I need to think about is, what's the highest power that occurs for 3? So we see 3 happen in the first one and in the second one. So the first one here, the second one here. So really it's only just 3 to the 1. So there's 3. Now we have 5. Well, 5 only actually happens in the first one. So 5 is right there, so that's the highest power of 5. And then we looked at 2. Well, we only have 2 in the second one, and the highest power of 2 is 2 to the 3. So in order to find the prime factorization, what we do is we take all these, the highest power that occurs for each number that occurs in all the prime factorizations, and multiply them together. So we take 2 to the 3 times 5, or times 3, I'll go 3 first, and then times 5. So that's the same as 8 times 3 times 5. So 8 times 3 times 5, that's 120. So that is the lowest number that will occur, that we get when we multiply 15 or 24 by a number. So we can check and see what that number is. So 120 divided by 15 is 8. So that means that 8 times 15 is equal to 120. And 120 divided by 24 is 5. So 5 times 24 is also 120. So we would have had to list out at least 8 numbers in our list to get this. So we'd have 8 in for 15. So that would be the lowest number. So you can see that gets kind of cumbersome. This is why the LCM via prime factorization is very useful. All right, let's try it a different way, or different numbers. So let's actually try 3 numbers this time. So let me see if I can find 3 pretty decent numbers. So let's go 24 and 36 and maybe, let me see, let's go 48, I guess. So 3 numbers that we're going to do the LCM for. So 24, we'll start, let me write my primes over again over here. So it's divisible by 2. So that's equal to 12. 12 divided by 2 is equal to 6. 6 divided by 2 is equal to 3. So there's my L. I hear my young feller downstairs having a little meltdown there. We've all been there, haven't we? 36 divided by 2. So if you hear any screams, don't be alarmed. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 3 is 3. So there's my L method. I'll write them out in a second. 48 divided by 2 is 24. And really, once you have a number that you've already done, you can kind of guess where this is going. It's going to have this repeated with an extra 2, basically. 24 divided by 2 is 12. But for the sake of completeness, I'll just write it out. And guys, once you get good at it, like the L method, it's a way to get you going. Like the way to help you understand. And some people in math love a method. So I like to give names to everything. In class, oftentimes we'll have I'll have a method named after almost every single student throughout the year. So, it really helps people remember. So that's why I like to make up names for stuff. So I don't know if there's in some textbook there's this L method. I have no idea. We just did this in class, and that's what we decided to call it. So, all right. So 24, 2 to the 3. So if your teacher's like, you use the L method, what the hell is the L method? Well, the L method is something that I sort of named, and then it's probably out there somewhere. I'm not going to take credit for it, but it's what we call it in my class. So it's really useful. The kids love it, so that's what I like. So 36 is 2 squared times 3 squared. And 48 looks like 2 to the 4 times 3. So this one's actually really interesting. So remember, you look for the highest power of each number that occurs in the prime factorizations. So there are actually only 2 numbers that occur. We got a 2 and a 3, unlike in the last one where we had a 5. So we look for the highest power of 2. Doesn't matter which one it comes from. It can come from different ones, or it can come from the same one. So the highest power of 2 is this guy right here, 2 to the 4. And then the highest power of 3, we got a 3 to the 1, a 3 to the 1, and then we have a 3 to the 2. So that's the highest power of 3. 3 to the 2. So my LCM is equal to 2 to the 4 times 3 to the 2. So that's 16 times 9. And I do not want to make a mistake in a math video, so that is 144. And there I am. So there's my lowest common multiple, 144. So guys, I hope this video helps, and you can definitely see the usefulness of prime factorizations. Thank you for watching this video, and I'll see you guys in class, hopefully, and good luck in your studies.